Anakin, I guess it's a random name, Star Wars guy. Anakin is sitting at his lifeguard station on the beach. Maybe it's Tatooine or whatever that Star Wars place was, when he sees a swimmer signaling for help. The swimmer is 125 feet out to sea. So here we go. Here's the person out there on a straight line between the swimmer and the shore. There's a straight line 125. And Anakin Station is 190 feet, 5 feet down the beach from the nearest point on shore to the swimmer. Down here, there's a lifeguard station. See the diagram, which is for illustrative purposes only, not scaled. Right, right. Anakin can swim at a rate of 2 feet per second, and he can run 5 feet per second along the beach. So he can run faster, swim slower. We want to find how far Anakin should run from his tower down the beach before entering the water and swimming the rest of the way to get to the swimmer as fast as possible. That's the key thing, right? When you get out there. So, in other words, he runs faster. So the further he goes down here, that's great. But you might think, well, just run all the way and then just swim straight. Yeah, but the diagonal, is going to cut off some of the distance. So there's somewhere where it's best to actually, run and then stop and jump in the water and swim. He runs faster than he swims, yeah, runs faster than he swims, but the diagonal is still nice to cut off some of the distance. So, if he swam at equal rate with running, then he would just go straight like that. But no, it's faster to run down the beach somewhat and then swim. So anyway, where's that point? So it's kind of a silly little question here, but there's things in real life people program and they set up systems, computer systems, security systems, things in military that do all this kind of thing that maximize the best way to make something happen like this. All right. The distance Anakin should run down the beach, we will label X. So let's call this X. So this is X from there. Here, let me do a better job there. From there. Oops. That's how far Anakin should run down the beach. Okay, we will label X. Then it says if Anakin runs down the beach X feet, how far will he need to swim diagonally to reach the person? Write a formula for his swim distance in terms of X only. His swim distance in terms of X only. Oh, okay. So then we're going to call this, here, let me call that S. Whoops. That's S. That's how far he's going to swim. His swim distance. So he's going to run a certain distance X, swim a certain distance S to reach the person out there swimming. So they want a formula for S of X. So, okay, how do we find that? How far should that be? Well, it's a little right triangle, isn't it? And this is the hypotenuse of a right triangle. So we're going to use a squared plus b squared is c squared. But first, right, so let me write that down. So in general, we're going to use a squared plus b squared is c squared, the Pythagorean theorem, because we have a little right triangle right here. And but what's his bottom part? Well, let me put that in here. That must be what? What must it be? Must be 195 minus x. Why? Because the whole distance is 195 and that's x. So the whole distance is 195. Take away x. This is 195. Take away x. That's the leftover, right? So there's that. This is 125. So now we can do the Pythagorean theorem. Remember, when you do the Pythagorean theorem, whenever you have a right triangle, you can use the Pythagorean theorem, a squared plus b squared c squared. Make sure you know which one is c. This one's got to be the c, and this is the a and the b. The a and the b can be switched around, doesn't matter, but make sure you get the c right. That's got to be the longest side, the side across from the right angle, called the hypotenuse, right? Remember all that? So that would be what? 125 squared plus 195 minus x quantity squared is s squared, the swim distance squared. So now how do we solve for the swim distance? We're going to square root it, aren't we? Whenever do one side, two to the other. So there it is. That is the swim distance, which is what we have right here. Square root of 125 squared plus 195 minus x squared. So that's the swim distance in terms of x. Now, write a formula. Next, there's three questions. Write a formula for the time Anakin, actually, just three. Write a formula for the time Anakin runs along the beach in terms of x only. Run time. What's his run? You see the answer there. How'd they come up with that? What's his run time? Well, it says here Anakin can run 5 feet per second. That's how fast he runs. So remember the relation between distance, rate, and time. I call it the dirt equation. Actually, I had a student many decades ago say that. You mean the dirt equation, Mr. Heron? Yeah, that works. Distance equals rate times time. Distance equals rate times time. So we want to know the time. So then if you want to find time, just divide by r. Time is d over r. So it's distance. So how far is he going to run? X, right? That's how far he's going to run. Over his rate. How fast does he run? He runs 5 feet per second. Here we go. 5 feet per second. There we go. And then finally, write a formula for the time Anakin swims. Well, again, time is d over r. So we already have the distance Anakin swims, right? This right here. This is the distance. The swim distance is that formula right there. So we put that over 2 because that's the time. I'm sorry, that's the rate. That's the rate. And this is the distance. Distance over rate. That will give you time. So there we go. We take that distance and put it over rate, distance over rate, and that gives you the time. So that's how long he spends running. That's how long the time he spends swimming. And that's all we're going to do on this. And this is just a setup problem. But then on another problem, we'll finish this up and we'll say, okay. So if this is how long he runs, this is how long he swims. Add those together, we get the total time he runs and swims before he reaches the swimmer. And we want to minimize that, right? So we'll take these guys and take the derivative and set it equal to 0 to get the minimum. We'll find x to find the minimum time to reach the swimmer. That'll be on another problem. This one is just the setup. And so there we go.